Hello everyone and welcome to today's workshop. My name is Ribarshid and I'm gonna be making an Arduino control obstacle avoidance robot car today. So this workshop will include the coding part of the robot car. It's gonna include the assembly. It's also gonna show a demonstration video. It's gonna show all the wiring connections and yeah, we're gonna learn how to use the sensors. Let's get started. Alright, so before I start today's workshop, I'm gonna talk about what the assembly is. So assembly is basically a smart lab based out of N5 since December 2014. And since then we have run over 250 free workshops for people of all ages, whoever is interested in learning about new technology or how specific softwares are used. So basically our workshops are divided into three types. So there's hack, code, and data science. So hack is about embedded systems, IoT, hardware. Then there's code workshops, which include software projects like APIs, frameworks, and applications. Then there's data science, which are related to advanced topics such as artificial intelligence and machine learning. So for this specific workshop, you can say it's a hack and a code workshop because it has hardware connections and it has also coding part to it. So it's a combination of hack and code. So our target audience is mainly students, professionals, entrepreneurs, but it's open to anyone who's interested. So our focus is mainly on smart technology and practical applications. And you can visit our forum on members.assembly.ae. We are also very active on our social medias, so you can find us on Facebook, Twitter, Instagram, or YouTube, or visit our website, which is assembly.ae, to keep up with the latest updates and to keep up with the workshops, which we run every week on Saturdays. Okay, so now let's start the workshop. Now I'm going to give you an overview of what we're going to do today. So we're going to make an Arduino controlled obstacle avoidance robot car, which is gonna avoid obstacles on its way by measuring the distance using ultrasonic sensor and the servo motor. So basically, it's gonna if there's an obstacle on the way, it's just gonna change its direction randomly, and it's gonna keep moving continuously until you turn it off. So what will you learn today? You will learn about Arduino programming, as we're gonna use ultrasonic sensors. So we will have to code. We will have to use conditional loops just to tell the system what it's supposed to do when a specific criteria has not been. If the distance value, suppose it's lower than the preset value, so it's gonna change accordingly. So it has a lot of coding. So you're gonna learn about Arduino programming, then you're gonna learn how to assemble and design a robot car, and we're gonna 3D print cases for ultrasonic sensor so that we can mount it on top of the car and on chassis. and we're also going to use one for the servo motor. So you will learn how to do that. And you will finally learn how to work with sensors, as I've mentioned before, making all the connections and all the wiring diagrams are going to be given. We're going to discuss them in detail. So this is the car that we are going to make. You can see it in the picture. The car uses a servo motor mounted servo-mounted ultrasonic sensor to detect obstacles in front of it and change its direction accordingly, as I have mentioned before. So it's going to look something like this, similar to this. So now I'm going to talk about the hardware required. So first, there is obviously Arduino UNO board, which is the best board to get started with if you're a beginner with coding and making new projects. So this is the best board to start with because it's very robust. And then there are 4 DC motors, which are used to enable movements in all directions, front, back, left, right. And then there is a motor driver. So the motor driver is going to be used to control all 4 motors which are going to be installed on the chassis of the car. So it's going to control all 4 motors individually. Then we're obviously going to use ultrasonic sensor. So the ultrasonic sensor, as the name indicates, ultrasonic sensors measure distance by using ultrasonic waves. The sensor head emits an ultrasonic wave and receives the wave reflected back from the target. Ultrasonic sensors measure the distance to the target by measuring the time between the emission and the reception. So we're going to use that to measure the distance, and the car will avoid obstacles accordingly. Then we're going to use a buzzer to generate sounds whenever there is an obstacle on its way. Whenever it's changing direction, it's gonna give a beep, so you will know that the car is about to change the direction or if there is an obstacle on the way. Now and then we're gonna to power the Arduino and the motor driver. We're gonna use a 18650 3.7 volt lithium polymer batteries. So these batteries are used because they have a high capacity, and it can give a combination of 7.4 voltage, and if the voltage is below 7.2 volts, the car will not work. So we need at least 7.4 voltages supplied to the motor driver and the Arduino. Then we have the power connector, which will be connected to both the motor driver and the Arduino, and it will be connected to the lithium polymer battery as well, so that it can power both at the same time. Then there is a voltage meter, which is used to indicate the voltage that is being supplied to the car. So the voltage meter has to indicate more than 7.2 volts for the car to work as desired. Then there is servo motor. So servo motors are electronic devices that rotate and push parts of a machine with precision. For this workshop, it is used to move the direction of ultrasonic sensor at various angles to cover 270 degrees, so that it can look everywhere, like front, left, and right, to see if there is an obstacle. Then we're going to use jumper wires to make the connections. Robot car chases can to mount all the elements together, and you can either 3D print them or purchase them online. But yeah, you can. It's all the design part. Like, you can just do it. It's up to you. And then we need wheels, 4 wheels to enable movements. This is the wiring diagram for the installation of the 4 geared motors onto the motor driver, and also the motor driver's power, how the power supply is going to be connected to the motor driver and to the Arduino. So as you can see, the 4 motors are connected to the K1, 2, 3, and 4 of the motor driver, So the bottom right is connected to the bottom right part. It's basically the motor which is in front of it, like it's aligned, so you can just the connections for the motors are very easy with the motor driver. You just have to plug it in wherever the motor is placed. Just make sure that the motors, they're connected on the opposite sides. So, and then for the power supply, the positive is going to be connected to the positive, and the negative will be connected to the negative of the ground. For the motor driver, you will make the connections from the ground, and for the power supply, you will just make sure the polarities match, and then you can just plug it in using the power cable which we discussed before into the Arduino. And then both of them are going to be powered. Just make sure it's 3.7 volts. Sorry, make sure it's more than 7.2 volts. Okay, so this is the assembly and circuit setup of the obstacle avoidance robot car. So I will discuss the connections now. So in the first picture on the left, that's an ultrasonic sensor, and the connections are shown over here. So the ground ultrasonic sensor is connected to the ground of the Arduino UNO board. The echo pin is connected to pin 11 of the Arduino board. Trig pin is connected to 12, and VCC is connected to 5 volts. So the trig pin is the trig pin from it's used to trigger the ultrasonic sound pulses. Echo pin produces a pulse when the reflected signal is received. The length of the pulse is proportional to the time it took for the transmitted signal to be detected. And then VCC is basically powering the sensor, and ground is grounding it. Then there is a buzzer to produce sounds. So the buzzer's connections are very simple. Ground is going to be connected to ground of Arduino. 3.3 volts is going to be connected. The VCC of the buzzer is on Arduino, and 13 is going to be connected to input-output pin of the Arduino. And now these are the connections between the motor driver and the Arduino. So just make sure these connections are proper, because even if one connection is missing, the car will not function as you want, as desired. So the connections are like this. So from the Arduino, so the motor driver has enable A, enable B, input 1, 2, 3, 4, and a signal pin. So but first I'm gonna tell you the connections. So the connections goes like this. So input 1 of the motor driver will go to pin 2 of the Arduino. Input 2 will go to pin 4 of the motor driver, will go to pin 5, and B will go to pin 6. Input 3 and 4 will go to pin 7 and 8 of the Arduino, respectively. And the S pin, the signal pin of the motor driver, will go to pin 9 of Arduino. So I'm going to tell you what these pins are. So basically, enable A pins are used to control the speed of the front motors, and are used to control spinning direction of front motors. So basically for enable A, if the pin is high, the motors will spin, and if it's low, then the motors will stop. Input 1 and 2, if both pins are either high or low, the motors will stop, and if one of them is high or one of them is low, then the front motors will spin. And for input 3 and 4, it's the opposite of input 1 and 2. And enable B is the opposite of enable A. For example, enable B, if the pin is high, the rear motors will spin. And if it's low, then the rear motors will stop. And input 3 and 4 as well, therefore responsible for the rear motors. So yeah, that's the connection between the motor driver and the Arduino. And then there is also a servo motor connected to the motor driver. So the servo motor is going to be used, as we discussed before, is going to change the direction of the ultrasonic sensor so that it can look front, left, and right. So it's going to enable those movements. So the connections are the wire of the servo motor is going to be connected to the ground, which is ground basically, and the red wire is VCC, is going to be connected to 5 volts of the Arduino board, of the motor driver, sorry. And the yellow is going to be connected to the signal because it's going to tell the servo motor which or what direction you're supposed to move. As for the software requirement and installation process, you have to get the latest version of an Arduino IDE, or if you have an older version, it's fine, it's still gonna work. So we will provide you with the code in the description below. So just all you have to do is connect Arduino UNO to PC with USB cable, open Arduino IDE, click File, and then click Open, choose obstacle.ino. So this is an INO extension, so even if you just click the file like that, it's gonna open in Arduino. So it's up to you. But the code that we'll provide is gonna be in obstacle avoidance folder. So load the code into Arduino board. So you have to choose, make sure that you choose the it's different for each laptop, so just check it. It has to say Arduino. So the port has to be correct, and make sure that you select Arduino UNO board and then upload the sketch. So first of all, I'm going to tell you all the components that you'll be needing. So first of all, you're going to need an Arduino UNO board, and then you're going to need 4 DC motors and a motor driver. Over here, I've already attached them to the chases. Then you're going to need a power supply cable to power both of them. Then you're going to need a voltage meter to display the voltage. Then you're going to need a servo motor, and for the servo motor you're going to need to either 3D print or purchase a case so that you can easily mount the servo motor. So I have printed this. So then you're going to need ultrasonic sensor. This is also, the case for this has also been 3D printed so that it can easily mount on top of the servo motor, and it has been attached to the gear. Then you're going to need a buzzer for generating sounds, and then yeah, you're just going to need some jumper cables and of course the chasers on which you're going to mount all the elements together. So let's start with the assembly. So first of all, I have already attached the Arduino UNO board and the buzzer onto the chases, and I've also attached the 4 DC motors and the motor driver onto the chases. So I have 2 chases, one is for the upper part and one is for the lower part. So all the motors have been attached to the lower part, the board has been attached to the upper part. So first of all, we're gonna install the servo motor onto the upper chases. So let's get started. So I have screws for this. These are the screws, and then we're gonna go and okay, now we're gonna attach ultrasonic sensor onto the case that we have, and then we're gonna put this on top of the servo motor like this. Just keep it straight and make sure to align it, and then we're gonna put the screw in between so that it goes inside the servo motor. Okay, so now we have installed the servo motor and the ultrasonic sensor, and we have also installed the buzzer, now voltage meter as well, which will go over here. Alright, so we have installed all the necessary components. Now we have connect the 4 DC motors onto the motor driver. So as I mentioned in the slides, so this one would go to this one would go to this one for this, and this one for this. So these are all aligned in the same way. So this one we would just plug it in into K2. This one will go to K1. This will go to K4. And this one will go to K3. So basically this one would control this, this would control this, this one for this one, and this is for this one. That's the connection for this. Now we need to connect the power supply. So you just need to give the car a voltage of more than 7.2 volts, otherwise the car will not work. So this wire, you would just put it over here into the ground of the motor driver, right over here. So we are going to connect a power bank and 3 batteries in series to generate a voltage of more than 7.2 volts. Or an easier way is just to purchase a lithium polymer battery of 3.7 volts, which are going to be connected in volts. So this is the positive. So this is the power connector. So it has a positive and a negative. So put the positive into the positive and the negative into the negative. And then this would later on go into the Arduino to give it power. So let's just leave it for now. Let's move on with the connections with the ultrasonic sensor, the buzzer, and the voltage meter with the motor driver and Arduino. Alright, so let's make the connections with the Arduino first, then we will make the connections with the motor driver. First, we will make the connections for the buzzer. And we're going to be using these jumper cables. So the VCC for the buzzer will go into 3.3 volts of Arduino board. Now the connection for the buzzer has been done. Now we're gonna make the connection for the ultrasonic sensor. So we're gonna need the jumper wires again. So the ultrasonic sensor has 4 pins, ground pin, echo, trigger, and VCC. So we're gonna connect the 4 jumpers to these 4 pins. Okay, and now the ground pin will go to the ground of the Arduino. Then the echo pin will go to number 11, and then the trig pin will go to number 12. Trig pin will go to number 12. And finally, the VCC will go to 5 volts on the Arduino board, which is over here. Yep. So these are the connections for the ultrasonic sensor. Now we need to make the connections for the servo motor with the motor. Now from here, all the connections are going to be made to the motor driver on the lower chassis of the car. So first we're going to connect the servo motor so the ground of the servo motor is the brown wire, the red wire is the VCC, and this the orange one is for the signal, telling the servo motor what like what angle to spin, to rotate. So we have to connect this to a pin, 5 volts and ground respectively. So the signal pin will go first. It's going to be S. So this connection is done. Now all the connections that we're going to make are going to be very congested, so just stick with me. So let's make the connections. So pin number 2 of Arduino board will go to, just use the holes that are given through, or you can just, yeah, just to make it neat. Okay, pin number 2 will go to input 1 of the motor driver. So the motor driver has enable A, B, input 1, 2, 3, and 4. So number 2 will go to input 1, which is the second one. Alright, so I'm just gonna connect all of them together, and then it's gonna be easier to know which one is where through the colors. So there are 6 pins over here and 6 pins over here. So I'm just gonna connect all of them together. So these 6 wires are connected to enable A, B, input 1, 2, 3, and 4. Now we're gonna make the connections. So we're gonna pass the wires through the hole and onto the upper chases where the Arduino is connected. So we're just gonna check where the connections are. We can just bring it out from that side. Easier. Okay, so pin 2 is connected to input 1. Pin 2 is connected to input 1. Wait, so we're going to start with enable A. Okay, enable A connected to pin 5. Pin 5. 1, 0, 1, 2, 3, 4, 5. Then it's input 1, which is connected to, input to pin number 5, not 4, 5. Then input B is connected to pins, after input A there is input 1, input A to pin 5, and then input 1 is connected to pin 2. Then input 3 is connected to pin 7. Input 3 is connected to pin 7. Then input 4 is connected to pin 8. Then input 4 will go to pin 8. 2, 3. Sorry. 2 will go to, input 2 will go to D4. Input 1 will go to 2. 2 will go to 4. And then 3 will go to 7. And then 4 will go to 8. And then we have enable B, which will go to pin number 6. Alright, so I forgot to make the connections for the voltage meter. So the voltage meter has 3 pins, one for ground, one for VCC, and one for UT, which is just going to VT, which is just going to be 0 volts. So it's just going to display the amount of voltage that's being supplied to the Arduino board and to the motor driver. So let's make the connections. So the pink one is for ground, the gray one is for VCC, and it's for VT. So the connections are going to be, so the ground is just going to go to ground of the Arduino board, of the motor driver, sorry. So it's where you pass it through here. So yeah. Wait, we're gonna need different wires for this. We need a female to female, like 3 female to female wires. So it's gonna go to ground, 12 volts and 0 volts. So it's 0 volt is the first one on the motor driver. Then it's 12 volts. And then it's ground. And then this pin will go here. And then this wire will go here. Yep, they're done now. Okay, so the 0 volt is connected to the white one, so the white one will go to VT. Then 12 volt VCC is connected to the red wire, so it's going to go to VCC. And then the blue one is the ground, so it will go to ground. And then there is one more wire that needs to be connected, which is from the signal from here. And will be connected to the signal pin of the motor driver. And then this is going to be connected to, no, it's going to be connected to pin number 9. Yep, that's all the connections you need. Finally, we're done with the connections. Now all I have to do is connect the wheels onto the lower chases of the car. So it's going to be this one, this is number 2, and then number 3, and number 4. And now you will just assemble this on top of it. Now that's it for the assembly part. Now it's all coding. Now uploading the code to the Arduino. So you plug this inside this, like this. That's all. Now we'll show you the demonstration after uploading the code to Arduino board. Alright, so now I'm gonna be talking about the code. So I'm gonna provide you with the link to this code. It's gonna be named obstacle, and the folder is gonna be obstacle avoidance. So when you open the folder, you're gonna find a file called obstacle.ino and configure.h. So obstacle is gonna have main code, and all the initializations and configurations are all given over here in the configuration file. So let's start. So first, you need a servo library, which is already there in most Arduino IDEs. If you don't have it, then just download it. You can just get it from Arduino website. And sorry about that. Yeah. And then, so we include servo library, we include configuration.h, which I just talked about. Then this is for the servo motor head. We initialize, this is for the motor control. So go advance, when this function is called, the car will go forward. And these are the pins which are for the motor driver. So it puts if it puts a pin on the left and right, the rear pin on the left and right high, and these two on low, then the car will go forward. And for reverse, it's the opposite of forward. So the front pins of left and right will go high, then the car will go reverse. And for the left, it's the same method. The left and right, front and back, if they spin, then the will make the car go right. Then if all of them are low, then it stops. So basically the digital right pin, it's used to give a high or a low value to a digital pin. So yeah, that's why digital right is used. And these pins are all defined over here. Motor direction, this one and is connected to number 2 of the board, all of that. And then now to set the motor speed, analog right function is used. So function motor speed, it takes input speed, left speed and right speed. So these are all predefined in configure.h. Speed L and speed, all of them are inputs to this. So analog right function is used to write the speed into an analog output. So that's for the speed control. And then this is the buzzer. So whenever buzzer is whenever we want the buzzer to go on, a digital right is given, the buzz pin is set as low, and whenever we want to turn the buzzer off, the buzz pin is set to high using the same digital right. Then for the alarm, whenever alarm is called, it will turn the buzzer on, and then after a delay of 100, the buzzer will go off. So the buzzer will not go on continuously. That's the reason why alarm is used. Otherwise, then it will stay on for like till whenever the batteries run out. That's why alarm we just defined both of them with a delay of 100. Now this is used for detection of ultrasonic distance. So the function is called watch. So it uses the trick pin, set them as low, the trick pin which I defined in the presentation. So trick pin, it will set trick pin as low, and then after a delay of 5 microseconds, the trick pin will go high, and this is how it communicates. It measures detects the distance using the trick pin and the echo pin. So then again it turns low, and then echo pin will go high. So we get the echo distance, and then we turn the distance into centimeters by multiplying the echo distance by 0.01657. And then it returns a rounded value of echo distance. Now, this is going to measure this function watch rounding. This is going to measure the distance to the left, right, front, and left diagonal, right diagonal, and assign them in centimeters to the variable. Right can wall, left scan wall, center, left diagonal, all of these 5 points for distance testing. So this is the variable obstacle status. So this is gonna basically telling that there is no obstacle on the left, or there is no obstacle in front of the car right now. So one is just the default value. So these are the 5 distances that are these are the 5 values, binary values that are gonna change. So if there's an obstacle on the left, then it's gonna be then it's going to be 1 0 0 0 0 if the obstacle is on the left, and if it's on the left it will go right, and if it's on the right, suppose 1 0 0 0 1 1, then it's going to go to the left. So for the center, it's gonna call the function watch, which we just discussed. It's gonna measure the distance, and we're gonna get a rounded value of equidistance, and then uh, it's gonna check if the distance is less than the distance limit. If it's less than the distance limit, then it's gonna call the stop function. That means the car will stop and the alarm will go on. The buzzer will go on for a delay of 100 milliseconds, and then it's gonna stop. And then the obstacle status will be updated using using the condition. It's gonna change the first three values, and then after a delay, it's gonna call then left diagonal scan ball is gonna call watch again, and the same function will be repeated for all of them. Just the delay value will change. So if it's less than distance limit, then it's gonna stop the car, alarm will go on, and the obstacle status will again get updated. And now again we use head right to change the direction of the servo motor, how much it has to spin. So over here I use 170 because 180 is not because my servo is not able to take this angle, so that's why I used 170. So then again, delay of 100, then again we call the watch function for the left scan ball, and if that's less than the sighted distance limit, then again we stop the car, alarm goes on, obstacle status gets updated. This keeps going on and on and on till it goes back to its original position, and then once it's done looking around, so it goes like left diagonal, center, then right, then left, and then it basically goes here and then there and then straight back. So when it goes to 90, it's basically finished looking around. So it looks forward now. We have to align the sensors so it looks forward now. It's automatically done. And then obstacle string is basically just it returns a 5-character string standing for 5 direction obstacle status. Then this function auto avoidance, it merges these two functions, watch and watch surrounding. So for auto avoidance function, we set the motor speed. These are all again in configuration.h file. Then first of all, when you start, like when you power the car, it's going to go forward. Then the number of cycles will increase by 1 every time, and then if the number of cycles it goes more than or equal to 80, then it's gonna watch for obstacles. So it's gonna stop once 80 cycles are done. It's gonna stop, and then a watch surrounding is gonna be called. Function watch surrounding that we just discussed is gonna be called, and then it's gonna check the value of the binary by 5 digits that we get the binary value. So if the binary value is 11100, that means there's an obstacle on the left. If the value is 1100 or 10100 or 0110, all of these values, that means there's an obstacle on the right. So the car will go, no, obstacle on the left, so the car will go right. So go right function is called, and then turn time delay. So the car there's a delay of the specific value, which is again defined in configuration.h, and then the same thing. This is for the right, and if there's an obstacle on the left, then the left-sided values will become 1, and the car will go left. Basically, yeah, the right-sided values will become 1, and the car will go left. And the same procedure. And if there are obstacles, if more than like 4 values become 1 at the same time, then that means there's an obstacle in the front and the car cannot go forward, it has to go back. So go back function is called, And the motor speed, the reverse motor speed is set, which is again in configuration.h file. So it's the reason why all these variables are defined in configuration.h is just to make the code look much neater, as you won't have to define each variable or just scroll up just to check out the value or anything. You can just literally just go over here and see all the values are given over here, and you can just change these whenever you want. And then yeah, that's it. And then the distance, the watch function is called to get the distance. So watch function to see if this, if anything, is ahead. And then if distance, if there is something, then it's going to compare to distance limit. The robot will just stop if it is completely sure that there's an obstacle. So if there's an obstacle ahead, it will stop and go back. And if there is, that means there is an obstacle in front of it. And if the distance is more than distance limit, then it becomes 0. So it basically resets it. 5, since something is ahead, it stops to move. And again, it resets. There is to 0. And then this is just the this is just the setup. So pin mode is used to give to tell if the pin is an output or an input. So it's so all of these are set as outputs, and echo pin is set as input, trick pin is output, and then start stop, buzzer off, and yeah, that's all for this. And then in the main loop you just call auto avoidance, because auto avoidance call all the other functions that are needed. So yeah, I'll just go through the configure file for a minute. So yeah, so see, all of these variables are predefined. This is the motor direction. It's set pin 2, motor direction pin 4, and this is also for pin 6, needs to be a PWM pin to be able to control motor speed. And the same for this one as well. These are the front and these are the back. No, this is a front and back. This is a right side of front and back. Then the servo pin is connected to number 9, echo pin to number 11 for the ultrasonic sensors, these two. Trick pin for number 12, buzz pin for the buzzer, and this is for the motor speed, the back speed that we just talked about in the code. And then these are all the left scan wall, center, right, where this ultrasonic sensor is going to move, measure the distance and all of that. And distance limit is 30, you can change it. High distance limit is also 30, you can just change it to whatever value you want. And the number of cycles are set to 0, they're all initialized, and these are integers, these are constant integers, so these will stay constant. These are also constant integers, so you can just change them, and then there is yeah, that's all. That's all for the coding part. Now I'm going to show you the demonstration. Alright, so now I'm going to be connecting the car to the power supply, and let's see how it works. So I've connected batteries and power bank in series to give it a voltage of more than 7.2 volts. So now I'm going to connect and it's going to start because the code has been uploaded. So as you can see, it's giving a voltage of 9.3. Now it's going to start. It's been kept inside this, surrounded by walls, and you can see it's measuring the voltage and changing its direction accordingly. The alignment of the ultrasonic sensor can be done manually. So, yep, that's a demonstration. Alright, so that's it for today's workshop. Hope you guys enjoyed and learned something new. If you guys liked the video, give it a thumbs up. If you guys liked our content, then do subscribe to our YouTube channel and follow us on Facebook, Twitter, Instagram, and yeah, to stay updated with our more workshops, more cool workshops, and then hope to see you again next week. Bye bye.